Jumping in here, we've got our program that we created in the last lecture. We're going to go ahead and download this to the PLC. So it's compiling, everything's good, we're loading, everything's online, and check it out. Right away, all of a sudden, everything's just done, okay? We don't have any conditions on either of these operations. We've just got them running, constantly. So what happened here? We scaled our 2. Our value coming in is 2. And we scaled that from a scale of 0 to 4 up to a scale of 0 to 100. And it came out of 50 on the end. All right? Now, look at this. When we normalized the 2 from 0 to 4, what that basically did is turned it into a fraction, okay? So that's going to turn it into something, less than 1, assuming your value is between the min and max. And instead of 0 to 100, let's say we're looking at something like 5 to 25 psi, or 0 to 5 psi of pressure. So 0 to 5. And let's reload that again. Load it. Okay, so a value coming in is real close to 0, so we get something real close to 0 coming out. And let's put something like 8,000 in. So yeah. Now, when I set a value going in of 8,000, which is kind of in the middle, it comes out and it gives me, remember, I'm outputting an integer, so it's got to round it off, but it gives me something pretty close to the middle. So when I'm converting something from one scale to another, I need to use these two blocks in tandem. Normalize is bringing my signal in, and scale is what's going to send my final value out. The min and the max on normalize, those are going to define my input signal range. So let's pretend we were using like 4 to 20 milliamps. That would probably be a numerical value coming out of an input module of like 4,000 to 20,000, right? And let's say we're at 6.5 milliamps, so that would be something like 6,500. And then we're scaling that to something, let's say from like 32 degrees up to 212 degrees, right? So let's go ahead and load that, and there we go. So that 6.5 milliamps is going to translate to 60 degrees. All right? So that's what scaling is. That's what scaling does. And in this program, that's how scaling works. So